Namaste and welcome to Apna Gurukul Maths. One little step towards success. So today we are starting a very new chapter, class 9th NCERT chapter number 2, which says polynomials. And here we start. So we will, in this particular video, it will be just an introduction session, and all the terminologies which are required to understand this chapter. We will cover up an overview of this particular chapter in this video. So polynomials. So the first video on introduction of polynomials. So let's understand first of all, are we clear with operations of algebraic expression? Now, why am I shifting to algebraic expression is polynomials is a special type of algebraic expression. What kind of speciality does it hold? We will try to understand. Now, let me clarify the definition of algebraic expression first of all. So, what's an algebraic expression? It's a combination of variables and constants with the help of some mathematical operations. Variables are the numbers which are unknown, which we represent with by alphabets. It can be x, y, z. Generally, we represent it by x, y, z, w, x, y, z. And the constants are fixed values, which can be in the form of numbers or it can be in the form of alphabets as well. We will try to understand it in a little more detail as we proceed further. And obviously mathematical operation, plus, minus, addition and subtraction. So a combination of all these three variables, constants and all the mathematical operations is known as algebraic expressions. Yes, I hope that's clear. Now, are we clear with identities used for factorization? X plus y whole square, which is x square plus y square plus 2xy. X minus y the whole squared, x square plus y square minus 2xy. X plus y multiplied by x minus y, which is x square plus x square minus y square. I hope that is very much clear too. Now, are we clear with the process of factorization? Now, process of factorization, we try to factorize with the help of splitting the middle term. We try to factorize by taking out the common factor in the expression. We try to factorize with the help of different identities. Over here, we have three identities mentioned. There is one more identity which is called quadratic trinomial, where we split the middle term. I hope you can remember the splitting the middle term. So these are the basic things which we know which we must be knowing before starting this chapter. If in any case you don't remember that, so don't worry at all. As soon as we move ahead in the chapter, we will revise those things very fast and then proceed forward what is there in this chapter. So in this chapter, we are going to discuss about particular type of algebraic expressions which we call it as polynomials, and then we have to discuss remainder theorem, factor theorem. They are very important theorem when it comes to understanding polynomials and where do we apply it, and obviously its uses in factorization. How do we use remainder theorem and factor theorem while factorizing algebraic expression, or we rather will use the word polynomials now. Then how do we use the different identities, and obviously some more additional identities from the four. Already we know four identities, right? So apart from that, we will try to learn about 4 or 6 more extra identities in this particular chapter. So let's begin with understanding what exactly is a polynomial. First thing, are you clear with variable? I know you are. It's just the numbers which keep varying. So we represent it by alphabets. Constants are fixed values. Now, algebraic expressions of the form of a constant times a variable. What do I mean? You can see those examples: 2x, 3y, then 0.6z. Now, over here, as you can see, when we write 0.6z, 0.6 is fixed, it is multiplied to z. So this is an algebraic expression of the form of a constant multiplied by a variable. Okay, so I am very much sure you are aware of such type of algebraic expression. Now suppose that the constants are also unknown. Now I'll give you example where is the possibility of constant being unknown. In this case, constants are represented by small abc and variables are represented by xyz. Now, so far, whenever we discuss algebraic expression, we had a thought process that variables can be written with any alphabet. And I understand that your teacher also has always told that. That is absolutely correct. But from now onwards, since we are getting into more detailed of the topic, we must understand one thing. the letters A, B, C, D, they are used as a constant. Now, what type of constant we will study in a while. And the W, X, Y, Z, they are used as a variable. I hope that is clear. So let's take one example, or here, if we randomly take an example, it could be AX. So what is the meaning of A here is, over here the A is a constant, X is a variable. Now if you have AB plus C multiplied by X, that means over here AB plus C is a constant and only X is a variable. Let's take an example. A regular polygon where the side is unknown. Okay, the length of the side is unknown. So what will be the perimeter? Perimeter will be A times X, right? Why? Because A is the number of sides and X is the length. Over here, we have a random polygon. We also know that it's a regular polygon. Regular polygon means all the sides are equal. So what do we mean by perimeter? Perimeter means sum of all the sides. So what did we assume here? That suppose you have a quadrilateral like this. This is not a regular polygon. Let me draw a regular polygon so to make you understand it better. So I'll make a regular quadrilateral. Okay. So now over here we know that it has four sides, right? If we know the value of X, that is the value of length, suppose 4. So now we know the value of A, which is 4, and also we know the value of X, which I just gave you 4 centimeters. So it becomes 4, right? So that becomes 16 centimeter. Okay. That becomes your perimeter for this particular figure where the side length is this particular square, regular quadrilateral. Now, suppose you don't know how many sides that polygon has and you don't know the length also. That is when we use AX. Now you might be thinking, since both of them are unknown, why are we taking A as a constant and X as a variable? Very nice question. Let me explain it to you. Now what happens in such situation is, in such situation, for one polygon, X might change, but A will remain the same. If we drew one polygon at that particular time, X can vary, my dear students, but A will remain the same. For one polygon, suppose I drew one quadrilateral, right? Is there any possibility that for a quadrilateral, the sides will change other than 4? But obviously, we can change the length. Length, I took it as 4. I could take it as 6, 8, 10. But the number of sides will remain same, right? So that is where this concepts come in. So I hope that makes a lot of sense, that when do we take the constants or the fixed value also as variable, that is ABC. I hope that is very much clear. Now this is very important when it comes to this chapter. I took a little bit of extra time to explain this because this one is a new concept. We have never dealt it. So that's why I explained it. Let's define a polynomial now. Now let's take a few example of specific algebraic expression, some specific type of algebraic expression. For example, x square, 2x, x square plus 3x. I mean, x square plus 3x is a polynomial. 2y cube is a polynomial. Now, what is common in all these expressions? The first common thing is, in one expression there is only one variable involved. Do you observe that? What is the second observation? You can pause the video and quickly go through the examples. Yes, you observed it correct. Exponents in these observations or in these expressions are whole numbers. Why do I say whole number? Because exponents are possible. There is a possibility that exponents can be 0 as well. So according to these two observations, we define a polynomial. So what is the definition? An algebraic expressions with whole numbers as their exponents are called as linear equations in one variable. I repeat, algebraic expressions with whole numbers as their exponents are called as linear equations in one variable. I hope that makes a lot of sense. So for example, you can take example could be 2x, 3x square plus 2, and several other examples as well. So before we try to understand a little bit more in detail, let's look at the important terminologies what we need to understand in a polynomial. Okay, so 2x squared plus 3x plus 1, obviously it's a polynomial. Over here, this 2 which is multiplied with x square, it is called as coefficient. All of you know about this from the expression itself. X is the variable, the power which is raised to, like x square we told, right? So this square is nothing but the power called as power. So all the variables and constants which are multiplied together and they are separated by addition or subtraction, they are called as terms. And obviously the final one is called as constant term. Now constant term, I discussed just now that a term is a variable and a constant multiplied or divided together. One does not have a variable, but obviously it has a variable in the form of x to the power 0. We already know one thing, that any number to the power 0 is 1. So if we multiply 1 to any number, it will not change that number, right? So that is why we take that all the constant terms are multiplied by whatever variable we are dealing with in the polynomial. See, always remember, we only have one variable to deal with. So x to the power 0 is what we consider. Now my question arises, is 5 a polynomial? My dear friend, absolutely yes. This is called as a constant polynomial where the variable is raised to the power 0. Just now we discussed 5 times x to the power 0. Or you can take any example, 101. Is this a polynomial? Absolutely, because I can write 101 times x to the power 0. Yes. So what is the definition? Definition of polynomial: the variable is to be raised to a whole number. 0 is obviously a whole number, so that's how we get to say that 101 or any number is a polynomial, and that type of polynomial is called as constant polynomials. Let's try to identify with a few examples what are polynomials and what are not. So is x plus 1 a polynomial? What are the two things? Let's quickly go through the definition. With whole numbers as their exponents, right? And with only one variable. So one variable and exponent should be whole numbers. The power should be whole numbers. That is the two things we have to try to understand. So over here, x plus 1, obviously x to the power 1, 1, x to the power 0. There is only whole numbers in the power, and obviously there are two different sums. So this is a polynomial. Root x plus 1. What is the meaning of root x? Root x means x to the power 1 by 2 is nothing but root x. So is 1 by 2, 1 by 2 is the power. Is 1 by 2 a whole number? No, right? So this cannot be a polynomial. Now x plus 1 by x. 1 by x, we already know by the definition of exponents or the laws of exponents that 1 by x is nothing but x to the power minus 1. Is minus 1 a whole number? No, right? So x plus 1 by x is also not a polynomial. Root 2 times x. That's a very interesting thing. Now here, root 2 is not a whole number, but we don't have to look at the constants. Definition does not talk about the constant. Definition only talks about the variable x to the power 1, right? And 1 to root 2, we can write it as root 2 x to the power 1. And obviously 1 is a whole number. So this is a polynomial, my dear students. Now 2x plus root 5, obviously this is also a polynomial. Although root 5 is not a whole number, but root 5 can be written as x to the power 0, and this power is a whole number, and 2x obviously has a power, x has a power of 1, so this is also a whole number. I hope that makes sense. Now cube root of y. Cube root of y is nothing but y to the power 1 by 3. Is it a is it a 1 by 3 is a whole number? No, right? So this is not a polynomial. Pi x plus x square minus 1. Now pi is an irrational number. It is multiplied with x, but here we have x to the power 1, of 1 is a whole number, and obviously x square minus 1. So all the powers over here are whole numbers. So this is a polynomial. 2x minus 3y plus 1. This is very important, my dear students. We are only focused on linear equations with one variable. Over here, it is a linear equation because the power is 1. But there are two different variables, so we are not worried about. This is not a linear equation in one variable. This is a linear equation in two variables. Over here, root y square. Now you must be very, very careful. This one is a little twisted question I have kept. So root y squared, when you look at root y to the whole squared, so when I open the bracket, it remains only y, because root and y cancel out, because root y is nothing but 1 by 2. 1 by 2 times 2, 2 and 2 gets cancelled out, so we are left with y to the power 1. So root y square is nothing but y plus 1. So y plus 1 is obviously a polynomial, and that's how it's a polynomial. I hope the definition of polynomial and the differentiation of polynomial and a non-polynomial is very much clear. Let's try to quickly understand how do we denote the polynomials. So we generally denote the polynomial by p of x, q of x, r of x, or s of x. If the variable is y, now if the variable is x, we represent p of x, q of x, and all the others. If the variable is y, we simply represent p of y, q of y. Now it is read as p of x, p of y, q of x, q of y, and so on and so forth. I hope the denotion is clear. There is one more important terminology we need to understand: degree of a polynomial. What do we mean by degree of a polynomial? So the degree of a polynomial, the definition is, just a second, yeah, the degree of a polynomial says the maximum power to which the variable of a polynomial is raised to. I'll repeat, the maximum power to which the variable of a polynomial is raised to is called the degree of a polynomial. Now, how do we represent this degree? How do we find this degree? For example, x to the power 100 plus x to the power 1. Is it a polynomial? Absolutely. What's the degree? It's 100. Why is it 100? Because 100 is the maximum power to which this polynomial has. X square plus 2x plus 1. What is the maximum power? X square, right? 2 is the maximum power, so it becomes x square plus 2x plus 1. Y to the power 18 plus y square plus 2y to the power 10. What is the maximum power? 18. So the degree of this polynomial is 18. 2x plus 1. 2x plus 1, what is the power? It's 1, right? So the degree of this polynomial is 1. Why am I writing with highlighter? Let's change to pen. So it becomes the degree of this polynomial is 1. Degree is 1. Now, my question is, 2 is a polynomial. What is the degree of a constant polynomial? It is 2 times x to the power 0. That means the degree of a constant polynomial is 0. Always remember that the degree of a constant polynomial is 0. Let's get going to the next concept, that is standard form of a polynomial. How do we represent a polynomial? So a polynomial written in decreasing order of their powers is the standard form of a polynomial, right? For example, ax square plus bx plus c, where a is not equal to 0 and a, b, c are constants. Okay, I already discussed why do we represent a, b, c as constants. So where a, b and c are constants, so this is a standard way of writing a polynomial. I'll just quickly ask you a question. 2x square plus 3x cubed plus 1, is it in standard form? No. We just need to write it in decreasing order of their power. 3x cubed plus 2x square plus 1. That's all. Now we need not be worried about, there is no x term here, right? There should be one more x, right? So that we can neglect it, right? But whatever powers are available in this polynomial, they must be written in the decreasing order. That is what is called a standard form of a polynomial. Always, whenever we try to solve something, we leave the answer in standard form of a polynomial. I hope that makes sense. Now, quickly, types of a polynomial. Types of a polynomial, there are, whenever we classify something, it is on some basis. So we classify polynomials on the basis of terms and then on the basis of degrees. So how many terms are there? So if there is only one term, it's called monomial. If there are two terms in the polynomial, it's called binomial. If there are three terms, it's called trinomial. If there are four terms, it's called quadrinomial, and so on and so forth. If it has 5 quintillion, and we do not use more than that, so you can just remember till quadrillion or trinomial is more than enough. Okay, now if the degree, according to the degrees of polynomial, now first was number of terms which has, I hope you are able to understand the difference between terms and degrees. Degrees is the maximum power, terms is how many different terms are there in that particular polynomial. So according to degrees, we have linear polynomial if the degree is 1. Okay, degree is 1. If the degree is 2, it is called as quadratic polynomial. If the degree is 3, it is called as cubic. If the degree is 4, it is called as quadratic biquadratic polynomial. And there are so on and so forth. We need to remember only till understand till biquadratic. We don't go generally after that. So these are the different types of polynomials. We need not go in detail about that pretty much right now. Now, let's try to understand one thing. Maximum terms possible in a polynomial based on their degree. If we know the degree of a polynomial, can we exactly tell what is the maximum number of terms possible? Let's try to understand. If the degree is 0, that means it's a constant polynomial. How many how many terms can a constant polynomial has? Obviously numbers, right? Only one term is possible. If the degree is 1, so what how many terms? X plus 1 or 2x plus 9. Now only these coefficients and constant terms will change, right? The variable will remain same, but can you have more than 2 terms? Absolutely not possible. For a degree 2 polynomial, it will be the standard form is ax squared plus bx plus c. So standard form itself has only 3 terms. So the maximum possible, it can be 2 also. You can have a polynomial like 9x squared plus 1. Obviously this is a polynomial with degree 2. It has terms too. So we are talking only about maximum. Maximum possible number of terms is 3. If you have degree 3, then maximum number of terms possible is 4. So if I say if the degree is n, how many terms are possible? The number of terms possible are n plus 1. Right? So if we have to write standard form of a polynomial of degree n with one variable, how will you write? So we write it as p of x equals an x to the power n plus an minus 1 x to the power n minus 1 and so on and so forth, a2 x to the power 2 plus a1 x to the power 1 plus a0, because this one will be constant polynomial, right? Because there will be no x to the power 0. X to the power 0 is 0. I hope that makes sense. This is standard form of a polynomial with degree n. How many terms will it have? It will have n plus 1 terms in total. So this is the standard form of a polynomial of n degrees. Let me explain it in a little slow manner. P of x is a polynomial representation, obviously. So an is the nth coefficient of x to the power n. Now I have an is just a constant. An minus 1, an minus 2 and so on and so forth till a0 are all the constant values. And then an cannot be equal to 0, because if an is 0, the x to the power n term gets cancelled out, so that this will not remain a polynomial with degree n. That is what we have to focus on. In the previous few times back, here we wrote a is not equal to 0. Otherwise this will not be this will not remain as a quadratic polynomial, because x square means degree 2 polynomial is called as quadratic polynomial, right? So that is how we take care of. I hope how to represent the polynomial of degree n is clear for you. Yes, so let's go through a few questions of whatever we have discussed so far. So what is the degree of a non-zero constant polynomial? I'm only talking about constant polynomials where except 0. 0 is also a constant polynomial, but that is called as zero polynomial. So we will keep that a little bit separate. So what is the what is the degree of a non-zero constant polynomial? So degree of a non-zero constant polynomial is 4x to the power 0, right? So the degree is 0. 4 is a constant polynomial. Now what is the degree of a zero polynomial? Degree of a zero polynomial is not defined. Now you might be surprised with this answer. Let's try to understand why. Now when we talk about zero polynomial, what is the meaning? 0, that's all, right? So even if I write x to the power 0, 0 times 1, that will remain 0, right? Now instead of this, if I write 0 times x to the power 1, it will still be 0, right? Because 0 multiplied by x, let it be any number, it will obviously be 0. Now 0 times x square, it will still be 0. 0 times x cube, it will still be 0. So no matter what power I take to the variable of 0, the zero polynomials remains a zero polynomial. That means it is very, very, very difficult for us, almost impossible for us to define what is one degree of this polynomial, because any number can be degree of a zero polynomial. That is why we write not defined. Degree of a zero polynomial is not defined. So you can think about this in much more detail. If you still have doubt, comment down. We can discuss this in separate video if you have any kind of doubt regarding this. Now, right, let's do a few questions. Write a binomial with degree 30. A binomial. A binomial means two terms. Degree should be 30. So, x to the power 30 plus 1. That's all. Binomial means two terms, right? So, x to the power 30, it's the degree, obviously, plus 1. Or you can write x to the power 29. Only two terms, binomial, and a degree is 30. I cannot take any term which has a degree more than 30. Write a monomial of degree 101. I'm sorry, I missed out. Of degree 101. Monomial means only one terms. Degree should be 101. X to the power 101. That's all. Or 2x to the power 101. 102x to the power 101. 102 is nothing but a coefficient, right? So that is how we can construct different type of polynomial. I just took two examples and I hope that's more than enough. So in this particular chapter, we will only be focusing on one variable polynomials. Two variable polynomials will be discussed later, mostly in your class 10. And I hope the introduction video is really super amazing. The applications of polynomial, why the hell are we studying polynomials? It's because it has wide applications in modeling of various building. Let's suppose you go for modeling, designing of different buildings. Obviously polynomials is very helpful. It is very helpful to understand many different physical and biological phenomena in constructions works. Also it is very useful in financial planning. If you become a financial expert, obviously you'll be using polynomials. Now I will not just say that these are the applications. We will do many problems where you will understand how exactly do we use these kind of polynomials. Okay, that will be done throughout after we have completed all the topics in the chapter. I hope that makes a lot of sense. So with this, that's it for the introduction video. Thank you so much for your presence with me. Thank you so much for being with Apna Gurukul. I hope you loved the video. See you in the next video. Until then, keep smiling. Jai Hind.